I don't like numbers. Okay, look, my name is Mutwana. Let's get started. So, you face time, make sure you do leave a comments below so I know that people who want to watch this type of video, right? Now, without further ado, let's get started. Share the video, like the video. Let's get started without further ado. Now, so I hear a lot of women, or even some guys, this yo man, I don't like the numbers. The moment I see the numbers, I don't want to see that because it's one of the hardest things. That's what I hate from some. But hey, let me make this easy for you. Okay, let me make it easy for you. So, for example, we have a question right here. They say derivate. So, how to derivate meaning? Okay, so when you derivate, for example, if somebody, I don't want to go to the whole concept. Let's get to the question. Okay, like this one right here. When you derivate a constant number, you see you derivate with respect to x. Let's say 4. 0 because this is a constant number, it does not have an x. Okay, this is for the basic people who learn basic derivative. Okay, if somebody give you derivative, let's say 8 3x power let's say 8. So when you derivative, what you do, you see this number right here, you bring it to the back, so you multiply by anything which is behind. So it's going to be 8 times 3 equal to 24, and write your x where is that, the exactly position was, and then take the top number minus 1. So 8 minus 1 equal to 7. That's how you derivate these. Okay, so if somebody give you so there's a different rules of derivative. Okay, so we have a derivative table. I'm gonna attach below. So now in another case, when you have a loan, let's say of a function, and they say derivate this, when you say dx means derivate whatever you have with respect to x. So then you're gonna say, look, if it's in long, some people call long, some people call lean, however you can call it. Okay, however you're comfortable with. So now what you do, take on the function derivative, take on the that, whatever is in front of the long. So I'm gonna say will be f dash. When you put that dash, means you have already done derivative. Okay, the over what we have exactly f of x. Okay, what does that mean? I'm coming there, right? Little by little, see there's a long of it function. I'm coming there, show you for a reason. That's why I'm showing you this. When you start with the equation, it's gonna be easy. If somebody give me, let's say for example, the ln of, let's say 3. Every time I say 3, what's wrong with me? I like 3 number. Yeah. Okay. Okay. So whenever you have that, how did you say? Derivate whatever you have here. So means derivate anything which is in front of the ln. So I'm gonna say you have to derivate anything which is in front of the ln, which is 3x power 5, and then you over exactly what you have here. So 3x power 5. So when you can derivate what is there on top. How are we going to derivate? We say we're going to have to multiply this number with anything at the back. So 3 times 5 equals 15, and then write exactly how it is. 5 minus 1 equals to 4, and then you over by 3x power 5. So now it's the matter of simplification. You have 4x, and here 4x is going to go, so it means you left your 1x. It's going to be 15 over 3, and 1x at the bottom. But by 3, 1 by 3 equals 2, 5. So the final is 6, 5 over x. You understand what I'm saying? So now let's go to the business right there. So now since you have all the concepts, you understand all those concepts I've explained, let's go do this question. Easy. So they say derivate. So we want to derivate this right here. Right? Easy. Easy. I love this. Okay? How we make the number easy? Easy. Okay. So now we're gonna say right now. So you see, we got the first group, the second group. So I'm gonna say if I derivate fx, it's going to be f prime of x equal, and then I'm gonna write derivative of each one. So I'm gonna say d, since it's x, means you have to derivate what the first one, which is this one, and then with plus, there's a plus, there's a plus, and you have to derivate the second one, which is what is ln of x plus 5. So what we're gonna do now, we start by one. Look, if I can derivate 14, we say when you derivate any constant number, you get 0. So this is gonna be what? It's gonna be 0, and then with plus. Now we come right here. We say whenever derivate ln of whatever you have, take what you have, derivative, right on top, and then write exactly at the bottom. So we're going to say derivative everything which is in here, which is x, and then over exactly what you have that function. So we over x plus 5. So now the task we have is to simplify or to derivate what you have there on top. So that's a quotient. Quotient is the rule of division. So we have a rule of quotient. So that one on top, okay, so we're going to say 0 plus, so we're going to say here of x, which is this one here, equal, well, this is 0, so I don't have to write 0. I don't need 0, right? So we say, okay, derivate this one right here. So we're going to say if this is quotient, we have a quotient rule. The quotient rule say write the denominator the way how it is. So what is the denominator? Plus 5. And then derivate the numerator. So we're going to derivate the numerator. And then you minus. This is a rule of quotient in derivative. If you don't know that, let me know. I'm going to type the link below for quotient division. Okay. Quotient derivative. Say division means quotient. You minus, and then you see you put the constant denominator, and then you differentiate. Now you switch the process. You say minus, and then now this is going to be constant, and then we differentiate the denominator. So differentiate the denominator, which is x plus 5, and then after that you over. Make sure you over. Let's put black color here. We over the square of the denominator. So square, what is the denominator square? Is x plus 5. Do we have to square? But remember, you still have this baby right there. So say, okay, so all of this stuff, so we can do like this, bracket, bracket, and then we have to over what we have right here at the bottom, x, and they say x plus 5. Okay, that's very interesting. I love this. So what we're going to do now is the matter of simplification. Okay, let's go. So then I'm going to say, for that case, I can raise this on the top so we can have some space here, right? I don't want to write at the bottom. If they say, oh, I didn't see you, the way how you write there, I got confused. You could have written on top. So that's what I'm doing this, right? It's going to be easy for you. Come on now, you raise. And take a time. Sometimes it's being edited. I got the new calculator today. Oh, I'm so happy. The soft calculator. So we're not going to have a problem raising and stuff no more. Okay. So what we're going to do now, we can simplify the bottom, and then we go with the floor. Okay. Now we go. So we're going to say now, if you differentiate this x, you're going to get equal to 1. So I'm going to say, well, so f prime. Let me write here. That's not going to be fair. It's going to be dating. My apology. Okay. So I'm going to say then, face. Okay, when you differentiate the x, you get to 1. So it's going to be equal to, we still have a square root of x plus 5, which is this one here. And when you derivate x, you get 1. And the minus, minus. This is x, this is x. Now, this when you derivate is going to give you 1 over 2 square root of x plus 5. This one right here, when you derivate, you get that. Okay? And then we over, it is equal. So we say we over. When you square this, means this and this going to cancel. So here it's going to have what? 5. Only x plus 5 because that's in this gone. Okay. So remember, let's do this. We can do this. Over. Let's do this. Let's do this a little bit. Let's write our x squared. Okay. Over. We over this one right here, which is what is x. And what? Square root of x plus 5. You understand? X plus 5. Okay. So now, make a space. We don't need this one. Okay. We don't need this one. Okay. So it's the matter of simplification. Okay, it's very, very easy. Easy. My grandmother told me, baby, go and break the world record mathematics. Okay, so now we say then we say this gonna be equal. Oh, I want to write it like it. Okay, equal to what? Okay, so now look, normal fraction. I can say this is over 1. Okay, so it's like you have this group and this group. So what we're going to do is say across. You find the common denominator between these. The common denominator is going to be 2x plus 5. Or you can say take this, multiply there, take this, multiply there, and the denominator multiply there too. So this one times that is going to give you 2, simply x plus 5. Okay? And then you minus 1 times x, you just say x. How did you get there? Like, I don't say, nah, it's easy. Come on, look. Let's multiply slowly. Say, how did I get this? That's what you're asking. Okay, look. These 2, 2. And then you got, I'll come back there, right? I'll come back and finish this part here. 2, 2. 2 just a 2, and then square root of x plus 5 times square root of x plus 5. So remember, in mathematics, if you have a square root of y times square root of y, if these terms are the same, you only get y. You don't have to write no both. But only if you just square root, not like only 3 and 4, no. Only it's like square root of something times square root of something. You see? Not cube root or fourth root. You know what I'm saying? So now, for that case, I'm gonna say, this is why I say I have a square root of this and square root of this. So I have a x plus 5 and then times 2 minus minus. You come here, just x times 1 equal to x. But remember, you multiply these two to have the common denominator. So we're gonna say our common denominator is gonna be 2 multiply 1 times then 2 square root of x plus 5. Okay, so that's the one on top, and they say divide. And the right, the one we have got at the bottom, however you can call it, x plus 5 on the bottom. Okay, so now you see there, we can cancel similar things in mathematics. You and you go to how. Okay, so then we say this same is say 2 times x, 2x, 2 times 5 plus 2, and then minus x over. So remember this and this cancel. So here we have what we have only 2 over, here we got x. So mathematical, in math, if somebody have, let's say somebody have c over d divided by k. If you have a fraction divided by letter, fraction divided by a number or one thing, this one thing is going to go to the top. Is acceptable. So for that case, now we're going to say, wow, x is going to come on here. Is a better acceptable if you have a group of two things, because look, top fractions like a one fraction divided by something, that's what it's going to come here. So it's going to come here. So for that case, now we're going to see equal to x minus x, simply equal to x plus 10 over oh, I forgot something here. See what I'm saying? I forgot something. You know what? Look. I forgot something. My apology. Look, you remember this one here? You forgot? Because if you find the common denominator for this two, means which is gonna be this. But I forgot this. Okay, let me say slowly, right? I'm gonna have to write this part. My apology. I'm sorry, guys. I'm sorry. Okay, I made some mistake. Okay, look my mistake, right? That you can learn from my mistake. Like, oh, you made a mistake. I saw you there. I see. Yes, I made a mistake. I agree. Because remember, look, in this we got that, but we have this one. How can we forget? So we say, oh, this divide. So let's do this. This and this give us 2x plus 5 minus x plus 1. This and this give us 2x plus 5. But we forgot this one here. So this is going to come here, x plus, and then we over, let me use another color completely here. We over, okay, I want to square over x plus 5, and then we have a rule. So what happened? Look, these should come here because we got fraction over a letter. So this is going to come on the bottom. So then we're going to have this, say 2 times x plus 5, 10. So 2x minus x, 2x plus 10. I think it's the same, right? 2 times x, 2x, 2 times 5 plus 10, and then we got minus. So 2x minus x equal to x plus 10. Okay, clear and crispy. Okay, so then we, well, remember it's gonna come here, right? We're gonna have 2 x plus 5 and then multiply by x plus 5. Let's see if x is equal to some time. I want to make sure everything's right here, okay? And then x plus 5, okay? Which is this on the bottom, it came here, x plus 5. Okay, you still have over x plus 5 or root. Excuse me, sorry. So you see here it's very easy. This and this is going to cancel. Now we'll finalize. For that case now, if this and this cancel, this is going to be, okay. This was like this. So I can just simply raise and tap. It's just long question unnecessary, but it's easy question. Easy question. I like long question. I don't know why. It's very interesting. So that we say here we left with x plus 10 over 2 x plus 5. So say 2x plus 5. Yeah, 2 yes, 2, and then x plus 5. But remember, all this stuff over x because of the bottom we got x. So now another things, this is gonna come in here because we got fraction over one thing. So finally, we're gonna say this is gonna be x plus 10 and then over 2 times just simply 2x x plus 5. So remember, they say you have to derivate, means this is gonna be f dash. It's gonna be f dash equal to, and if you come into the option, it's gonna be option number 4. Man, leave a comments, man. Let me know where you come from, where you're watching from. This one here. So this is gonna be option number 4. For that being said, man, there's a lot of things. I'm gonna do this question, but now in a fast pace. See, this is for the people who want to do in a fast pace. That I'm gonna do again with a fast pace.